Lesson 11.2. Analyze arithmetic sequences and series. An arithmetic sequence is a special type of sequence that has a common difference, which we'll call D, between successive terms. Now we had these in the last couple of lessons, we just didn't give them a special name. So when we add the same number each time in between. For example, 3, 6, 9, 12, 15 is an arithmetic sequence because we add 3, add 3, we add 3, we add 3. So our D here would be 3. So question, is that one arithmetic? Well, let's see. We add 4. We add 4, looking good. Add 2. Those are not the same, so it is, no, it's not arithmetic. Why don't you try number 1? Well, here you actually subtract 2, subtract 2, subtract 2, subtract 2. So that's subtracting, so it means it's not. Oh, but yes it is, because subtracting is the same thing as adding a negative 2. So yes, where D is negative 2. Now, we've already discovered this formula a couple lessons ago, but the formula for the nth term for arithmetic sequence is an equals a1 plus n minus 1 times d. And it is linear. It comes out to be linear. It looks kind of like y equals mx plus b. Let's write a rule for the nth term. Well, we need to know a1. Well, that's easy. That's your first term. And we need to know d. So what are we adding here? Looks like we're adding 15. Adding 15. All right. So our d is 15. So we have an equals a1, which is 32, plus n minus 1. And remember, n is your variable. It's like x, times d. And we just found d was 15. You do have to simplify. So 15 times n minus 15. And we end up with, well, 32 minus 15 is actually 17 plus 15n. See, it's mx plus b. It's linear. Why don't you try number 13? Pause this lesson while you try. We should end up with an equals negative 3n plus 54. All right, one term of an arithmetic sequence is a8 equals 50. The common difference is 0.25. Write a rule for the nth term. Well, we have an issue here. We know the d, but I don't know the a1. Remember, our formula is an equals a1 plus n minus 1 times d. But I do know this was an. So when n is 8, an is 50. So this is x is like 8 and the y is like 50. So we could actually plug that in. And we could find a1. So when n is 8, the an is 50. And our d is 0.25. So it's 7 times 0.25, which is 1.75. Subtract that from both sides and you end up with 48.25. Oops, that's not an n, that's a 1, sorry. So a1 is 48.25. So now we can write a formula. an equals a1, which we just found, plus n minus 1 times d. Distribute. 0.25n minus 0.25. Well, we can combine those and end up with 48 plus 0.25n. Why don't you try number 21? When you're done, you should end up with an equals 5n minus 12. Here's another type. Two terms of an arithmetic sequence are a5 is 10 and a30 is 110. Write a rule for the nth term. I don't know a1 and I don't know d. What I do know is that when n is 5, the an is 10. When n is 30, the an is 110. So my function is an equals a1 plus n minus 1 times d. Alright, so if I plug in my first one, an is 10 and the n is 5, which gives me an plus 4d. If I take my other one and fill it in, an is 110. It's a 1. I made the mistake last time. a1 plus n is 30, minus 1 times d. Equals a1 plus 29d. So now we have two equations here and two variables, a1 and d. So we can solve a system of equations. Well, maybe if I multiplied the first one by a negative 1, I'd have negative 10 equals negative a1 and negative 4d. Add those together, so we're solving by elimination. If 100 equals, the a1's cancel out. It's 25d. Oh, so d is 4. Now that I know d, I can plug it into one of these and find a1. So it appears like a1 is negative 6. So my rule is an equals a1 plus n minus 1 times d. a1 is negative 6 and d is 4. Distribute, so it's 4n minus 4. Combine like terms, looks like it's negative 10 plus 4n, or you might want to write it as 4n minus 10. Either way, there's your rule. Why don't you pause this and try number 33. Remember, you're going to have two equations where this is n and this is an. So you'd have 12, 8 minus 1 times d, or 7d. And you'll have 22 equals a1 times 16 minus 1 times d, or 22 equals a1 plus 15d. So take those two equations, solve a system of equations, finish working it out. All right, let's keep working it out. Multiply the first one by a negative 1, maybe. So it looks like we have, if I add these together, 10 and, what was that, 8d? So if I divide by 8, I'll have 10 over 8, which reduces to 5 over 4. Nice. It's a fraction. All right, let's plug it into one of these. Maybe that one. 12 equals a1 plus 7 times d, which is 5 over 4. Multiply those. You have 7 times 5 over 4. subtract. Remember, you'll need a common denominator. In this case, it'll be 4. So you'll have 48 over 4 minus 35 over 4, which gets you A1 is, 13 over 4. So now I know A1, and we know D. All right, AN is A1 plus N minus 1 times D. So AN is AN. A1 is 13 over 4. N is N, and D is 5 over 4. Distribute. So that'd be 5 over 4N minus 5 over 4. Combine like terms. 13 minus 5 is 7. And then 5 over 4n. Or maybe you wanted to write it as 5 over 4n plus 7 over 4. It doesn't really matter either way. So now we get to the sum of a finite arithmetic series. So we have this, 1 plus 2 plus 3 plus 4 plus 5 is, how would you add that up? Well, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. Or maybe there's an easier way. We could rewrite it. Take your first half, and then flip the second half backwards under it, and add. 1 plus 10 is 11. 2 plus 9 is 11. 3 plus 8 is 11. 4 plus 7 is 11. 5 plus 6 is 11. Wow, we'll have an 11 and 11. We'll have 5 11s, which is 55. And that pretty much gives us our formula. All right. This is half the number of terms, and this is adding the first one and the last one, or n times a1 plus an over 2. All right, consider this arithmetic series. 2 plus 8 plus 16 plus 14 plus ... Find the sum of the first 25 terms. Well, okay, so the sum of n equals n a1 plus an over 2. Well, I know a1. I know n is 25, but what is an? What is a of 25? So if I go on to the first 25 terms, I need to know a25. Well, an is a1 plus n minus 1 times d. So if I want a25, a1 is 20. N will be 25, and D, what is D? D appears to be negative 2. So that's 20 plus 24 times the negative 2, which is negative 28. So our sum of the first 25 terms is 25. A1 is 20. A25 is negative 28. Divided by 2. And that gives you, well, here, we can work it out really quick. 20 and negative 28 is negative 8 over 2. That's negative 4. 25 times 4 is 100, and it was negative. So add up all those numbers, get negative 100. Why don't you pause this and try number 41? So it looks different because they gave you the rule already. That's convenient. It is linear, which makes it arithmetic. So you can just use the sum formula. Sn equals n a1 plus an over 2. N here is 20. So n is 20. A1, how am I going to know A1? Well, just plug in a 1. This would be 2 times 1 minus 3. AN. Well, N is 20, so plug in a 20. Look at that. We know everything. All right, let's start here. 2 times 1 minus 3 is negative 1. 2 times 20 is 40. Minus 3 is 37. 1 plus 37, negative 1 plus 37 is 36. 36 over 2 is 18. And 20 times 18 is 360. Of course, you could use your calculator and plug it in. Let's say you put money in the jar at the end of each week. The first week you put $2 in the jar, and each subsequent week you put $2 more than the previous week in the jar. Wow, it'd be nice to keep that up. All right, so write a rule for the amount of money you put in the jar at the end of the nth week. All right, so the first week you put in 2. The next week you put $2 more, so 4. The next week you put $2 more than that, so 6, and then 8, and then 10, and then so on. All right, so it appears like D is 2, so AN is A1 plus N minus 1 times D. A1 is 2. N minus 1, and D is 2. Let's distribute. 2n minus 2. Notice the 2's cancel. Which you probably could have gotten from the pattern. It's 2 and 2 times 2 and 3 times 2 and 4 times 2 and 5 times 2. How much money is in the jar after 9 weeks? Well, that sounds like a sum. Since it's arithmetic, our sum is n, A1 plus AN over 2. So I want 9, so my n is 9. A1 is our first, so that's the 2. And AN, it's 2 times n is our formula, so it'll be 2 times 9 or 18. And of course, 2 times 18 is 20. 20 divided by 2 is 10, and 9 times 10 is 90. So you'll have $90 in your jar after 9 weeks.